Okay, good evening, everybody. So let us continue the class. Okay. So today we'll start with some other techniques, statistical techniques. So today we'll start with the Monte Carlo stimulations. So anybody can tell what is this Monte Carlo stimulations in statistics? So as you can see in Monte Carlo stimulation, we can take in account the risk and quantitative analysis in decision making. That is what is the Google tells the definition for the Monte Carlo method, in which if you are when you are doing some probability calculation, probability studies, so you are acquainted with the risk factors, and it helps you to take the decisions. Okay, this is the statistical. I won't say the statistics because I'm not dealing with the statistics for this, but we will go ahead with the work. Okay. So take this particular course. We will be taking some. We'll generate some pseudo random numbers and we'll create the stimulated data for this work. Okay. Yeah. Run the code. This is the usual codes we are using for the last experiments. So next we will be creating a t-test statistics or t statistics under the null hypothesis. So everybody, I think, are able to get the first three codes. This is common. So in this t-test generator, we are giving the cases for your sample population from the control. You can see the control population. What we have taken is from the mice phenome, and the control population we have taken the from the data sex equal to F and diet equal to chow. And using that, we have created the case. In this case, we have control population for N, and for the controls. So again, we have taken the control population, and we are generating the t-test for this. Okay, so you are developing the histogram for the t-test. So you can check out the t-test, the data which is created by just giving the t-test, and you can see it. Instead of that, you can give the head command and you can execute it. Head of t-test. Then let us go with the QQ plot for the t-test. So we have created a stimulation, that is Monte Carlo stimulation of 10,000 occurrence, sorry, 1,000 occurrence, using the variable whichever you have used it. So in the t-test, when you give it, you see 1,000 generated numbers. That is the random variables, 1,000 generated variables. So now you have given, you have reduced it, you have given in your, sorry, yeah, initially you are given replicate as 1,000 and t-test generated as 10. Here you are giving t-test replicate as 1,000 and t-test generated as 3. Even you can draw a histogram if you want. So now compare with the original data. Initially you generated the simulation with the 1,000 random numbers. Now you are creating the QQ plot for the normal, that is the control population. So initially you are given the t-test directly with the function n, that is n, and later you are given that n as 1,000. Here you are defining it like mean is 24 and standard deviation is 3.5. and you can see the t-test. Done, everybody. After this, you can run all the codes again and see the difference. So this is not ending here. The thing is, you can rerun the codes again by giving the specifications. Initially, you gave as random by selecting 1000 replicates. So now you can change it with specifying some other replicates here, and you can run the particular functions. Okay, everybody got this? Everybody got this? Yes or no?
Yes, sir.
Okay. Why nobody is replying? Only one person replied. Alex, Chinmay, you got it?
We got the result, sir. I'm analyzing the code now, sir.
Okay. Divya, Gayatri?
Got it, sir.
Sir, I am facing error.
Got it, sir.
Who is facing error? Divya. Okay. Priyanka, Milan, Raja, Priya, Milan.
Yes, sir, got it.
Okay.
Yes, sir.
Sai Divya and Shravani?
Yes, sir, got it.
Okay. So in this Monte Carlo simulation, initially here it is the main. You are keeping the replicate as 1000, and later you can change the replicates and see this is the predicted simulations you are given. Now you are getting all the risk factors, and then you can change it and you can check the difference here. Okay, let us shall we move on?
Yes, sir.
Okay. Now let us go with the permutations and combinations. Anybody can tell what is permutation and combination? Mainly what is permutation? Anybody? Statistics? Anybody can tell? Permutation, what you do?
So permutation is all the number of combinations of different numbers arranged in a sequence or something, sir.
Further? So let me try to give you some it is still loading. One moment, yeah. So as Alex told, permutation and combination both are way of arranging the numbers. So permutation is the arrangement of the items in which order matters, in the way how you are arranging it. So number of ways of selection and arrangement of the items in which the order matters. In the combination is a selection of the items in which the order does not matter. Okay, so that is a simple thing, as Alex told, way of arrangement. Okay, let us move on. So use the first three commands as usual. So here we are randomly shuffling the data in the control and the treatment. Sorry, cases and control levels, and so you are replicating, given 1,000 times you are shuffling the data. Since you are given average replicate as 1,000. I shared the courses. So let us check the p-value using the code. Okay.
So is it possible to get different p-values?
For the replicates, if you are changing, you will get it.
But using the same codes, I get a different value, sir. Using the same codes that you sent, I got 0.0519.
Okay. Yeah, replicates are there, no? In each and every replicates, once you are changing it, it will change.
Okay, sir.
Yeah. Here you can even check the new treatment and new control every time. Because what is happening every time, it is for the 1,000 replicates, it is changing. So and for the So here you have created the association as 5 and you are doing the permutation studies here with the association which what you are given as 5 here, and you are getting the codes. Here you can change it to n equal to 10 and you can check it out the differences. And replicate you can also change it and check it out. Yeah. You can see the differences here using the if the combination is of 5 and if the combination is of 10, you can check out the difference. Okay. This is your permutation. Got everybody? You can try with the both, and you can even check the combinations and you can check it out.
So for the value of 10 an error has come. Error in sample int length x size replace problem. Cannot take a sample larger than the population when replace is equal to false.
Which one you get n equal to?
10.
Okay, for initially you gave 5, then you are given as 10.
Yes, sir.
Which one, here or here? The next one, the course I shared, it is 5. Sorry, it should be 10 here, 5 here. Initially you gave 5, then I gave as 10, right?
Yes, sir.
Then why it is the difference? I also read it, no? This is actually this is 10, this is 5 for me here. See, if this is n is 5 and I got this. Try to do it again.
I'll try, sir.
Yeah, error should not come. Others are getting the same error. Anybody for n equal to 5 or 10?
Even I got the same error.
You did
Sir.
change, you changed here or here?
No, I wrote a new code altogether, sir.
Huh?
I added the code you just sent on the chat, sir.
Okay.
At the bottom.
Huh.
For 5, when I replace 10 with 5, it's giving me no problem. But once I add 10, it says error.
Okay. It is like from the top, yeah, from the maximum to the minimum. Okay. First you can do with at 10, then you can do it 5. Then you will not get the error. Sorry. Yeah. But you should not get the error. Why? Because you are putting the value here, and it should not give the difference.
So when I ran the values of control treatment and OBS diff again, and then I ran the program, it's showing me no problems.
Yeah. Because from here you are taking control, you are getting the sample of control. Okay. Here the error can come because already the control is taking the sample of the initial value. That is why the error is coming. This line. Because if you are giving 5 and then 10, then the error will come. Because here it is already samples will be 5.
So basically, the value from the previous data is interfering with the new one.
Yes, exactly. This is, see, initially if you give here as 5, then if you give here as 10, then it will be error. That is the thing, because you can check it out, no? Control sample, control n. So what initially the control value will be, if it is 5, it will be 5 here. If you are changing to 10, then it will be error. Good that you are getting the error so that you can understand the codes better. Okay, shall we move on? Because error is coming here. Shall we move on?
Yes, sir.
Okay. Next, we'll go ahead with the association studies. So, before that, I want to tell you, anybody is having any idea regarding this GWAS? So, we'll do some studies, very small studies with the GWAS now. Anybody can tell me what it is?
Sir, we study your genetic variation with a particular disease.
Yes, Chinmay, you had attended that GWAS workshop.
Yes, sir.
Yes. So we had taken the disease as well as control population, and we were doing the association. So the simple definition I got from your this one NIH, it is the approach used in genetics to study to associate specific genetic variants with a particular disease. This method involves scanning in the genomes of the many different people and looking for the genetic markers that can be used for the detecting a particular disease. Okay, so we will do only the association studies here, and we will not take any particular disease, just we will give the disease and we will do it. Okay, so let us to go ahead.
So basically, it's the using data to find RFLPs, sir.
Yeah, we will get the this one. RFL will get this one. What is this? SNPs. Mainly this is the SNP studies. Here we will not directly take the SNPs here for the codes here. We will just do a association with the disease and the control. Okay, so first let me give you the first code, because we are doing, actually here we are doing it very blindly. You will understand it. Okay. So what we have done here, we have taken 250 individuals. So blindly we are leveling the individuals as diseased and non-diseased. Okay. This is just a blind study. The blind association we are doing it, where some of them have given disease, others do not have, and we have just taken it that 20% of the people have a allele of AA for the disease, and 10% and the remaining 10 will be having the different allele. It's just a random distribution without any specific scientific study. So you can see here disease, no disease is given, just factor. So 180 people, they are having one particular type, again 20 another type, 40 another type, and 10 another type. So the total is your 250. Labels, control, and cases. That's it. So when you are reproducing this particular code, you can change the numbers and you can put any specific disease if you want and go ahead. It is just a blind association. So you have disease control, you have 63 having the genotype AA and A. You can see it here. This is some just you are given a random data for your work, and this is your data. So in your genotype table, you have the genotypes as capital A, and capital A, small a. You have 200, and with small a, it is 50. So did I show the okay table disease and table genotype? So in the disease table, you have control of 220 and cases 30. Okay, that is your study you have designed for yourself. It is you are not taking any particular data from anywhere, you are just doing it randomly.
So,
Yes,
sir, how's this calculation about 250?
it is just random calculation. Huh?
Okay, sir.
It is just random calculation. It is, I told you, no, this is non-scientific distribution. This is you are giving the data for yourself for the analysis. That's it. Last time in the workshop, we had taken a particular data set and we had analyzed it. We had even taken the SNPs which are responsible for the disease. Here, we are just making a random data set for the association. That's all. You can even change the values after the class when you are doing it your own. You can change the values and you can do it. Otherwise, you can take any particular data set. Actually, I will take for you separate class with the particular data set. This is just I am giving you. Maybe in the next week, I will take a particular data sets and I will execute it for you. It is just that association you are doing it. So what you have to got so far genotypes you have for the control as 180 and the cases that is the disease as 20 for the genotype capital A and for the small a genotype you have control of 40 and cases as 20. This is your work means this is your data set as I told you. So let us take the p-value for the disease cases. Don't get confused here. This is the p-value you are taking. Now I am giving based on the p-value the expected table. It should look like. This is your expected. So it should have your genotype control. It should have 176. It is having 180 cases at 24. Here it is 20. The control it should be 44. You are having 40 and 6 here. This is the expected table. So take the chi-square of the p-value. So now you are making the linear models. Check it out. Okay. This is the table. We are getting the standard error, z values, and the p values with the estimate. It's for your linear models. So you will in the next you will be checking out the linear models. Now even take the confidence interval and check it out. Confidence interval. Okay. So here I am not even taking the SNPs or anything, the disease factor. It is just a random association studies using the like what is the these are initial studies with the data set. If you are taking for the GWAS, initially you can analyze the particular data or the sample whichever you are getting it. Okay, it has nothing to do with the proper because in the GWAS initially I told you regarding the association with the disease with the particular SNPs that you are not doing it here since you are just giving it randomly. You are giving some of the cases for your disease data. That's all in this particular association study because this is just a simple association studies. Everybody got it?
Yes, sir.
Okay. So here we will be doing the exploratory data analysis of the various plots. We are seeing it, but with the particular few data, we will see the various plots. So shall we move on? Everybody has got it?
Yeah, sir.
Yes, sir.
Okay. Okay. See here you have to download a particular package called using R. For you have to install the package. Just check it out if this library's command is working. If it doesn't work, you have to install the particular package.
It's working, sir.
Okay. Everybody, the library package, if it is working, it is fine. Otherwise, you have to install it again. You have given two. One is library using R, other is Rafalab. Rafalab, yeah. So for the random distribution of this, you are generating the quantile plot here. That is a QQ plot. Then you can give it as X and see what is the data you have got. That is the father height with respect to the son height. Actually, if you're directly using this particular using R, that this particular data set is automatically coming in your system. Sometimes you don't even have to generate load the data set from the package. It comes automatically. Prepare the QQ plot for the X. Okay, here you are giving n equal to 1000 and x, you are assigning the value of a normal value, the I think normal distribution value of n, and you are generating the QQ plot. Got everybody?
Got it, sir.
Got it, sir.
Okay. So here you are giving some specific values and you are generating, you are giving the defs as the particular values. Check it out, it will take. Yes. Here you are generating a plot from a data which is taken directly from your R package using R. So you are giving a histogram. You can see here HISTEXCT.py. That is the one particular data. So you are giving the histogram and the no QQ plot for the data. Now you will be doing the scatter plot for the scatter plot for the height of the father height and the son height. This is the plot for the yeah. So library using R should be there. Data father son, x height of father, y son. Then you are plotting it. Yes. Correlation between the height of father and son. If it was there in your correlation and regulation studies, so like this you can even plot it. Next, we can create a blocks plot for this same father, height of father and son. So next, I think everybody got the blocks plot for the height of father and son. So next, it is a normal plot between of the height of father and son. Okay. This is the, if you are doing if you in the correlation, you are doing any correlation studies. Finally, if you are you can plot the data for the correlation using in this manner. Okay. So got everybody?
Yes, sir.
Yes, sir.
Okay. So this is actually correlation studies. Okay. So let us move ahead with the regression. One moment. Anybody can tell what is regression? What
Or
is
a downward
regression?
trend.
Huh?
A downward trend.
For what is correlation? and what is regression? What is correlation and what is regression? Downward trend, okay, fine. What is correlation and what is regression? In regression, what you are doing it actually? So in correlation, the degree to which two variables move in coordination with each other, we see in the height of the father and the son. In regression, a return to the former or less developed state, a measure of relation between the mean value and corresponding values of the other. Actually, here what we are trying to figure it out also, that any missing value if it is there. Okay. Okay, let us move on. Okay. So using your initial data, you can read this data female mouse weight. The one characteristics in regression is if at all any missing values are there in any data set, you can find it out. Okay. So here we are finding relation between the two data sets we'll be using. One is two functions, mainly is the matrix model and matrix model functions. Okay. There's one more function here that will be formula function. Yeah. Formula. Initially, we did not assign any values, just check it if you are giving any value to the group, what is the changes happening. Okay. So giving some values and checking out. Initially, you just gave this factor and got it. Now you are giving the values and you can check out the how it is taking it. You are increasing the factors. So finally, you are combining all the data which is given, that is a diet and sex, and see the combined. So you are using everywhere the matrix model function. So now if you have to reveal any particular group, so how will you do that? So you have made the group factor 1, 2, 2, 2, and you want to reveal the group 2. Okay.
Sir, could you send us the above codes
Which
from
one? I
the
did not-
model.matrix?
No, I send it, no? This is the last code. Before that also I sent it.
Diet plus X, that one, sir.
It is here, no? Diet. Which one I did not send you? Okay, 2 diets, okay. Okay, I will send copy from here only. So if you want to reveal the group 1 to 4, 1 to 4. Yeah. Then finally you can do the t-test. Okay, got everybody. Now we'll do little analysis with the genomic data. We'll download some genomic data and we will do the statistical analysis. So till here, almost all the statistical works are done. Let us go ahead with the now with the genomic data, how you can do the statistical analysis. Okay. So if this Dev tools is not installed, you have to install it. Done, everybody? Are you all doing this one? Genomic data analysis. The regression I think is done actually.
Yes, sir. Installing date tools.
Okay. So you are taken the genomic data, particularly this one. See, GSE5859 subset. Okay. Then you are doing the, you will do several analysis with the genomic data. These is, you are just taking the numerical data. You are not taking the from the genomic data. You are not taking the this one base pairs or the bases. From the genomic, you are just taking the numerical data here. Do not get confused here. We will not use the basis for this analysis. Done, everybody? Installation is over. It may take some time. Because based on this genomic data, actually you can process ahead with the basis data also. But basis data I will not go further. Base data I will just take with the Galaxy. That will be maybe in the next class. Today I will show you some of the numerical data from the this one genomics. Done, everybody? Why all are silent?
Sir, it's showing error, sir.
Which
It's still
one?
installing for me, sir.
Which error, where it is? Because if at all, if you are not taking this dev tool is not there, then you have to install the package.
Okay, sir.
Alex, Chinmay,
Still doing, sir.
okay. Divya, Gayatri,
Sir, I'm error for install GitHub.
okay. First, then you have to install the dev tools.
Yes, sir. Now it's done, sir.
First, you have to install this. As I told you, if it is, if there is any error coming, you have to install this.
Okay, sir.
Done, sir.
Okay. Just check it out. For me, it is already installed. Even this class is also installed. That's why I got the warning message. For if anybody who is not able to do it, you have to install that dev tool package.
So even after installing, it's like restart R prior to install.
Yeah.
Mm,
Restart R and do it.
okay, sir.
Here I am just using the this one. These are the cramp packages. Once if at all I install the bioconductor package, it will take a lot of time. Bioconductor also, I think next class I will take even that also. Few bioconductor packages. Because here I mainly deal with the statistical analysis using the biological data. So if we have to use directly the biological data with biological function, then yes, of course, you have to use bioconductor. Here also you will need bioconductor in this. Done, everybody?
Yes, sir.
Others? Shravani, Shruti,
Done, sir.
Rajapriya, Priyanka,
Yes, sir.
Jovita, Divya, Jovita and Divya.
So yeah, so it's again like I have to change the package from C to I don't know. It just got saved in C. I have to change the folder to E.
Which folder?
I don't know. This package, it's like it's
It's
saved.
a temporary file it will create. Once you are installing the package, it will the temporary file it will create in the C drive.
But then it says the downloaded binary packages are in C.
That is not a problem.
Then
It is
again,
just
I gave library. It says loading required packages.
let it load.
Okay, sir.
Let it load. What is the problem?
It's not loading, so it just showed red. The thing is in red.
It is in red.
Sir, I'm unable to install this GitHub.
I'll show you,
Installed
sir.
in the genomics
I'll
class.
show you.
Okay, one moment. Share the screen now.
So
Error
I'll
should not.
I'll send it in WhatsApp, sir.
Okay. This particular thing you have to install like this. It will happen. If this one you are taking it one by one, it will happen very easily. Install package, library dev tools, install GitHub. If not, you may, because already you have installed. Okay. If at all you have already installed R tools, it will not be a problem. It is fine now. Jovita, it is fine.
Okay, sir. So
Continue.
then why does it say it in red?
It is what it is written. Read it. Loading required package. Use this. Is there any error? There is no error, no? You should stop if there is any error. The error message is not there.
Okay, sir.
Then just try to install this GitHub.
Yeah, sir.
Divya,
Sir, I'm unable to install GitHub.
GitHub, why? What code? Did you give the same code?
Yes, sir.
Internet is connected with your system?
Yes, sir.
Then why it will not take? It should take it because instead is directly install GitHub. This particular command, just check it out. If it library is installed, dev tools,
Yes, sir.
developer tools, then it should come automatically. If not, then you have to install R. This is already I gave initially. R tool should be there.
I got, sir.
Okay. Because first you have to give the R tool, dev tools, the developer tools. If it is installed, then it will take automatically GitHub.
Yeah, sir.
Okay. So next you can load this library. Divya,
Sir, it is showing could not find function install GitHub.
GitHub library dev tools. What is the problem? The library dev tools is fine.
Yes, sir.
And library dev tools is there. Then GitHub function is for the dev tools only. Just rerun the R, close R, and then you start it again. And check it out if your working directory is saved properly or not. This will because the dev tools, this is the function. Install GitHub. developer tools. This is okay. Let us move on. So I have taken okay data, then dimension of the gene expression. Okay, then dimension of the sample info. Okay, so here you are using 8,793 samples. Sorry, gene expression data, in which 24 samples are there. So just check out your sample info. Head sample info. Okay, this is the proper genomics data. Even you can check out the gene expression data by giving the head command. Do not give without head command. Otherwise, you will land up in trouble. Anybody is checking the gene expression data? Check it.
Yes, sir.
Yeah. What you are getting in the gene expression?
It takes time to analyze what is written here, sir.
Okay. Did you give the head command?
Yes, sir.
Important head, yes.
Even with the head command, it's a lot, sir.
Okay. So in this, which gene expression you have taken, particularly GAC 5859. Check it out where it is. Actually, it is a complete one because already you have given subset. It is all subset of this. So everything it is here. This subset contains all this. Okay, let us move on. Divya, are you able to see your errors? Is it working?
No,
Divya?
sir. No,
Huh?
still showing the same error.
What?
It's not working, sir.
Not working. Okay, I will check after class. So give this dimension function of the gene annotation. Jovita, is it working?
Yeah, sir, I'm able to do it.
Okay. Give this head for the gene annotation. So in this manner, you are able to retrieve the gene data. I won't say it is a ATGC data, it is just the numerical data. Okay, let us go further and do some analysis. We just took the data, but we did not do the analysis here. You can take your own data and you can do further studies. Okay. Just execute this, we'll come back again. This is not needed actually. This is okay, let us see.
Cannot open the connection. In addition, warning message.
Which connection it is not able to open?
Cannot open file. Female controls population. No file or directory.
No file means your directory is mismatch.
Even I got the same. Sir.
Yeah, check out the directory. Did you check out this working directory? If this is wrong, means it will not read it. That's it. It is so simple. Divya?
Yes, sir.
Yeah, are you able to do?
Sir, I'm trying, sir.
Okay. Others? Shravani, Saidivya, Shruti,
Done, sir.
Rajapriya, Priyanka.
The same issue.
Who is having the same issue?
Myself, sir. Last year.
Rajapriya. Wait, check out with your working directory.
So even after doing with the working directory, it's the same.
Shruti?
Yes, sir. I got the sample info group. I got the answer of that. So I'm done.
Okay. If at all anybody is not able to read this file, female control population, please this one close the R and restart the R and then you try to read this. Because if it is not in the working directory, definitely it will not read. Check it out, everybody. You can close the R and then you can start it.
So I think it has something to do with the fact that we didn't actually save the file. We didn't actually save the file.
Then
So I'm getting the
nothing.
same, sir.
You did not save the file, nobody? Did you save the file or not? That female this one, what is this? Female control population. If that is the case, then I have to send your file. I don't know
Yes,
why.
I think we didn't save the file.
This is not. I told you that day only. Save it. I told you you could have used that option, that write save table, write table. Okay, let me. I only have to send it. If I did not give the command, nobody thought to save it. Though I told you to save it. Female control population and one more mice pheno.
Sir, is that the I sent on WhatsApp? Is that the one? Check once you can check, sir.
Yeah, that is the one. That is a URL, but it will not save directly. I have already sent the CSV file. It will redirect you to the place where this particular this is there. This data is there. Okay, save it and then read it. Done?
Done, sir.
Everybody, Chinmay?
Yes, sir.
Yes, sir.
Okay. Shall we move forward?
Yes, sir.
Okay. So till where did I? Okay. So histogram is done. Okay. All the other codes I have given you, please do it. Histogram is given, then library and data. So you need to go with the expression studies, gene expression data of row 25. because this is a this one big data. Big data you cannot analyze fully, so you're taking a particular row and you are analyzing it. It is not that you cannot analyze the complete row, but for you it will be difficult for you to understand. That's why a specific row is given. Then this library, if it is loaded, it is fine. Then QQ plot for your same expression data. T-test. Shailesh, are you doing?
Yes, sir, I'm following.
Okay. So check it out what you have done. This p-val you have created initially with your female sample population. This one you were applying with your gene expression data. The apply function is given, apply gene expression data. So now it is a little difficult for you. You will be installing this bioconductor package. I mean, do not run this command. Don't run this command. If you're running, it will give you an error. Yes. Now it will work. Bioconductor, it is specific for the bioinformatics status.
So an option is coming. Update all, some or none.
Okay, so everybody could install this bioconductor package.
So an option update all, some or none.
All. That is in general you can give it, because if at all any package there is error, it will be overcome. You can overcome it. Done?
Still installing, sir.
Okay.
Done, sir.
Okay. Another few plots I will give, then we will conclude for today.
Done, sir.
Okay. Everybody completed? Shailesh, Chinmay, Shravani, Shruti.
Done, sir.
Okay. Jovita.
Done, sir.
Okay. So another 10 minutes I will take and conclude for today. Give you some plots based on this data. This one we are generating the p values here. So now you are getting the plot for this. Yeah. Anybody can tell what is this plot? Anybody can tell?
Sir, is it volcano plot, sir?
Yes, to some extent it is volcano plot. Now let us you do the histogram. So for the p values, you have created one is null p values, other is p values. You have created the histogram. So check it out if this biobase is working. Because I don't think we have installed this package. Yeah, it is coming.
Biobase works, sir, but the following one doesn't.
Following one doesn't work because it is not there. It is 1 minute. Let me check it out. It is maybe it is a bioconductor package. One moment. It is a bioconductor package. Okay, just you can copy this and it should work. Now, how will you know if you ask that how to know which is a R package, sorry, CRAD package or bioconductor package? It is Google. So you can write the name of the package, you will check it out, you'll find it out, it is R package or bioconductor package. Mostly, since it is we are dealing with the genomics step, here we will get mostly the bioconductor package. Permission denied. Okay, I think it will not work. It is coming as permission denied while installing. So this particular is not working. I wanted to complete it today. I got stuck. All are facing the same error? Permission denied?
Yes, sir.
Okay.
Yes, sir.
Then I have to check it out. I wanted to complete another 2-3 codes were there. I don't know if the next codes will work or not. One moment, data is working. Data is not found. Okay. One moment. Okay, use this code.
It's working, sir.
Okay, no, good. Is it installed, this particular package for all?
Yes, sir.
Good, yeah. For me only it is not installed, for you it is installed. Then you can run the other commands. Just check out with the library, data, and GE. Okay. If for everybody it is installed, then you can go ahead.
It's working, sir.
Okay, good. Go ahead then. Go ahead and I think even the box plot I have given you. Yeah, box plot also you can
Done,
try
sir.
to do. Okay, good. Check out the other codes. You can do it. Mine is still it is loading. For other, you all can do it. Next one is histogram. Yeah, S histogram. Then I'm giving for the MA plot. Yes, I gave mat plot. Okay. Done for all. Then finally standard deviation.
Done, sir.
Okay, if it is done, it's fine. Okay, for me also it is done. I think my R has got stuck. From here, library. Okay, fine. So that is done for today. So I have completed you till the complete statistics, including the this one for genomic data. So that is numerical data for the genomics. So one more apart from this, one more line of course I will send you. You can do it on your own. Then from next class I will start with this Bayesian theorem. Bayesian theorem I will take for you, and this one clinical data I will give to you, clinical trials data. Okay, and then I will come to the machine learning part. Okay, after that I will discuss with you some of the projects. Okay, so any further doubts? Then I can any doubts you have in the class? Try to practice the data. One more set of codes I will give you. You can also do along with that. And one more thing I just wanted to tell you that today we used with one particular genomic data set. Okay, yeah. So take some other data set and try to execute it. Okay. All the commands will be the same. Only this particular subset also you can keep it, but try to change the subset and check and do the analysis. Okay.
Okay, sir.
Okay. Okay then. Thank you. See you all. Good night.
Good night, sir.
Thank you,
Bye.
sir.
Yeah. Bye.
Thank you,
Good
sir.
night.
Bye, sir.
Thank you, sir.